Okay, let's look at how do we recognize if an equation is balanced. So here I have two molecules of H2, 1 and 2. And then over here I have one molecule of O2. Remember that these are called our reactants. Okay? Over here, I have two molecules of H2O. This is known as our products. Remember, we have reactants react to produce products, or restroom to pee-pee. Okay? So we have this. So these are our reactants. They're going to react and they're going to combine to make something new. So that's what they've done. But we need to find out, do we balance? Because you can't have any more mass on this side than you have on this side. The amount of mass here has to match the amount of mass over here. All right, so let me take care of taking this off for just a minute. And we're going to set this up. Underneath your arrow, draw two lines. And inside those lines, you're going to write the symbols for each of the elements that you have. So we have H2, we have H, and we have O. Those are the two elements that are used in both our reactants and our products. On the reactant side, we have two H2s. So 2 times 2 gives us a total of 4. Okay? On the product side, for our H's, we have 2 times 2. So we have a total of 4. On the reactant side, we have one molecule of O2, so we have 2. And on the product side, we have 2 molecules of H2O. So remember that this 2 has to be multiplied by the subscript of 1 here. So 2 times 1 is 2. So because our numbers match here, we consider this to be a balanced equation. But let's look at it in terms of mass so that you also understand that this also applies to what's called the law of conservation of mass. We say that mass cannot be created, nor can it be destroyed. It can only be rearranged, which is what we've shown here. The mass of hydrogen, we're going to say, is 1. And I have 4 hydrogens. So 4 times 1 AMU for atomic mass unit equals a total of 4 atomic mass units here. My oxygen each has a mass of 16. So 16, and because I have 2, let's write this the other way. 2 times 16 AMUs equals 36 AMUs. So to add those two together, I'm going to get, 32 AMUs. I'm going to get a total of 36 AMUs. Atomic mass unit for the reactants on this side of the equation. When I look at it over here, I'm going to look at how many hydrogen. Again, I have 4. We know that the atomic mass unit for hydrogen is 1. So 1 times 4 AMU equals 4. And then again, I still have 2 oxygens. So 2 times 16 AMU equals 32 AMU for a total of 36 atomic mass units. So this number and this number have to equal. These numbers have to be the same in order for an equation to be balanced. Okay, let's look at this example here. The example up here is CH4 plus O2 yields to CO2 plus H2O. So I have my diagrams. I have my CH4, my molecule of O2. I have one molecule of carbon dioxide, and I have one molecule of H2O. Remember, anything on this side, on the left-hand side of the yield sign, is called the reactants. Everything on the right-hand side is called the products. Okay, so let's look. What elements do we have? We have a C for carbon, we have an H, and we have O. So if I look here, I have one carbon, which is here, and I have 4 hydrogens, 1, 2, 3, 4, and I have 2 oxygens, 1, 2. So this is the amount of atoms that I have on the reactant side. Over here, I have 1 C for carbon. I have 2 oxygen here, but I also have one over here. And because they're both on the product side, I have to add them together. So 2 plus 1, or 2 and 1, is a total of 3 oxygens. And then over here, I have 2 hydrogens. Okay? Now, when I look at this, my carbons match with 1 and 1, but my hydrogens do not, and my oxygens do not. So we would consider this to be an unbalanced equation. If we were to compute out the mass, the atomic mass unit on the reactant side versus the product side, we should also come up with a different number on both sides. So I have carbon. Carbon has a mass of 12, and because I have 1, I have 1 times 12 equals 12. We said hydrogen had a mass of 1, and we have 4 total. So 4 times 1 equals 4. And then I have oxygen, and we said oxygen had a mass of 16, and we have 2 of those. So 2 times 16 equals 32. When I add this up, I get 4 plus 4 is 8, and 3 plus 1 is 48. So on my reactant side, I have an atomic mass unit of 48. Let's see what we have on our product side. Over here again, remember I have a carbon. We said it's 12. We have 1. So 1 times 12 equals 12. I have 2 oxygens here. They're at 16, but I have a third one here. So now I have to do 3 times 16. Let's see, that's 1848. And then I have 2 hydrogens. We said those were 1. So 2 times 1 equals 2. And when I add this up, I get 12, carry my 1. I get a total of 62 AMUs on this side. Okay? So notice that my mass does not match. Because it doesn't match, it doesn't follow the rule of the law of conservation of mass. Therefore, it's considered to be an unbalanced equation. You don't have to work this part out. I just want you to understand what we're talking about when we talk about the law of conservation of mass. This is what you need to know how to do. You need to be able to count your atoms on the reactant side, and then count your atoms on the product side. And then you have to make sure, do they match? Are they the same for each element, or are they different? If they're exactly the same coming across for each element, it's a balanced. And if they're not, like it is here, then it's considered to be an unbalanced equation. Okay, that concludes today's lesson.